The two most important root finding methods we're going to talk about in Math 9 are the bisect method, which we've already talked about, and Newton's method, which I want to talk about in this video. So to motivate it, let me make a text cell, which we haven't done before. So instead of using the style of input, I'm going to use the style of text. So basically what that means is Mathematica, it's not going to try to evaluate anything I write here. It's just going to assume it's some text that I want you to read. So the goal is given a function f of x and a starting value x0. Find a value z such that f of z equals 0. Okay, in other words, so i.e. find a root of f of x. Okay, another way to say it is find a value of x where the graph y equals f of x crosses the x-axis. And what's the idea? Is we're going to set x1 to be x0 minus f of x0 divided by f prime of x0. Okay, then I'm going to set x2 to be x1 minus f of x1 divided by f prime of x1. Okay, and so on as many times as we want. So with any of these root-finding algorithms, or these algorithms in numerical analysis, we're never going to expect to find a 0 exactly. So these are just, we hope, better and better approximations. And what I want to talk about in this video is where does this strange formula come from? Okay, this strange formula that says x minus f of x divided by f prime of x. Where does that come from? And so what do we know? So I know that x0, f of x0, is a point on the graph. And I know that f prime of x0, okay, the derivative at x0, is the slope of the tangent line at that point. So what can I combine that to get? I can combine that to get the equation for the tangent line. So the equation of the tangent line at this point, x0, f of x0. Hey, what's that going to be? Well, I know the slope. I know a point on it, so that's enough to find a complete formula for it. Formula is going to be y minus the y value, so y minus f of x0 equals slope, f prime of x0, times x minus x0. So I can tell that the slope really is f prime of x0, because that's the coefficient of x here, and there are no other values related to x. And I know that it has the point x0, f of x0 on it, because if I plug in f of x0 for y and x0 for x, then I get 0 equals 0. So I do get a solution to this equation. So I know that's an equation of the tangent line. And remember, what I want is to know where does y equals f of x cross the x-axis. Okay, and instead what I'm going to find is where does the tangent line, okay, that's using all the information that I have right now, where does the tangent line cross the x-axis? And that's our best approximation for the 0. Okay, another way to say it is that's the best approximation for the root. So let's finally go into now an input cell. So if I go up here to Format and Cell, I see that it's under Input. And let me say I want to solve y minus f of x0 equals f prime of x0 times x minus x0. And I used the wrong equal sign. I should use two equal signs because I want these two sides to be equal to each other. And I want to solve that for x. And so far, all I've written down is the equation of the tangent line, but I want to know where does the tangent line cross the x-axis. So what does that correspond to? It corresponds to where does y equal 0. Okay, so I'm going to replace that y that used to be here with 0. And so what do I get here? Here I get negative f of x0 over f prime of x0 plus x0 times f prime of x0. So let me write that out in less strange terms. So I can cancel out some, like I can cancel out these two f primes. So I get, let me go up here. So if I cancel the f prime of x0s from the top and the bottom, what do I get? I get that x is, let me rearrange it, x0 minus f of x0 divided by f prime of x0. So that's exactly what I got before. Okay, that's exactly what I wrote up here for my next iteration. And so how can I do this in general? How can I automate this process? Well, I can automate it using nest or nest while list or NestList. So let me show you how to do that. So as an example, let me make let me choose that to be the pure function x squared minus 2. Okay, and for a pure function, I don't write x, I write this pound symbol. Okay, so just to convince you that that's right, if I do f of 1, then I get 1 squared minus 2, which is negative 1. And Newton's method, how can I get that? Let me get it using NestList. So what's my function? Well, the function isn't x. Sorry, the function isn't f. The function is variable minus f of variable divided f prime of variable. And let's start at 1 for my approximate root. And let's do it 4 times. And let's look at numerical approximations for this by putting it inside of capital N. And let's look at square root of 2. So we can see that this is getting closer and closer to a 0 of the function x squared minus 2.